Hey everybody, Allie here. My topic of choice for our video presentations was black holes. They have always been a mysterious wonder to me, and I've always been so fascinated by them, especially since it's so foreign to our basic understanding of the world around us. It's kind of like a shopping trip to Target. To give you a basis, black holes are formed when a star can no longer sustain itself and collapses under its own gravity. The gravitational pull is so strong that not even light can escape. But don't let the name fool you. Black holes are actually a massive amount of matter packed into a small space. Kind of like these cute little bunnies. Black holes can get even larger by absorbing more mass around them, usually from the accretion disk that surrounds them. Accretion disks are usually very large and hot and can travel at very high speeds. But there is a space between the black hole and the accretion disk known as the orbit. The accretion disk cannot get any closer, however light can because it has no mass. As of now, astronomers have identified 3 types of black holes, being stellar black holes that can have a mass up to 20 times more than our sun, intermediate black holes which are slightly larger and often more common, and then supermassive black holes. Astronomers have found proof of a supermassive black hole at the center of our Milky Way that's called Sagittarius A. It has a mass of about 4 million suns. In recent research of black holes, we found that because black holes warp space-time, it causes light to bend into the black hole. Derek Mueller explains it a little better on his channel, Veritasium. Here's the clip.
So what is the first light that we can see? It is those light rays that come in at just such an angle that they graze the photon sphere and then end up at our telescopes. And they produce a shadow which is 2.6 times the size of the event horizon. And you say, what are we really looking at here? What is this shadow? Well, in the center of it is the event horizon. It maps pretty cleanly onto the center of this shadow. But if you think about it, light rays going above or below also end up crossing the event horizon just on the back side. So in fact what we get is the whole back side of the event horizon mapped onto a ring on this shadow. So looking from our one point in space at the black hole, we actually get to see the entirety of the black hole's event horizon.
This short video clip gives you an idea of what a 3D model of a black hole looks like. The theory of black holes was first developed by a man named John Michell in 1783. Shortly after, a man named Pierre Simon came up with the concept of dark stars in 1796. But it wasn't until the 20th century that the term black hole was first used by John Wheeler. Last year, however, a huge breakthrough in science occurred. You may remember it because all your science teachers were freaking out. I know mine were, at least. But yes, the first legitimate photo of a black hole. On April 10th, 2019, Katie Bauman developed an algorithm using 8 ground-based radio telescopes known together as the Event Horizon Telescope to get the first photo of M87. In the image, you can see the plasma orbiting around the black hole. The bright region shows where the plasma is coming toward us, and the dimmer area is where plasma is traveling far away. This is called relative beaming. This hole is very active, which means that it's just constantly feeding on the matter around it. The black hole has 2 jets extruding from above and below, with one pointing almost directly at us. If you're wondering why the image is fuzzy, it has to do with how small it is. Although the black hole itself is very large at about 6.5 billion times the mass of our sun, it's so unbelievably far away that the image was extremely difficult to capture. This picture also supports Einstein's theory of general relativity that predicts a sufficiently compact mass can deform space-time to form a black hole. But what would happen if you fell into a black hole? Well, the outer boundary of a black hole is known as the event horizon. This is the border at which a gravity becomes strong enough to create the phenomenon. The closer you get to the center, the stronger the gravitational pull gets. Let's say you were falling towards the center head first. Your head would be traveling faster than your toes, which would stretch your body until it snapped apart. After that, your body would slowly disintegrate as gravity becomes stronger than the chemical bonds that hold your body. But let's be honest, we won't be falling into a black hole anytime soon. Thank you for watching my video on black holes. I hope you guys have a great day.